And thanks for taking the extra break here. And my name is Rob Chohan. I make offline maps for mobile. I have a rich presentation over here, but I have this presentation's online. It's always online. It'll be online. And if you can see up in the top left, it says mobilefirst.roblabs.com. That's what the entire presentation is. So let's see what this will do. I'm based in San Diego. I write a lot of software for mobile, web, and print, for making maps for mobile, web, and print. I post stuff out on Observable. And some of the things I work on is drawing directly to PDF, drawing directly to Mapbox, and drawing directly to SVG. All my code is out, it's open source out in GitHub. And then I have some products that I'm making. One is an Apple book, which I can't show you exactly, but we can click on that. And some mobile apps out there too. I'm not sure why these aren't working. Okay, but either way, I'll get started on it. So the talk here today is about offline maps for mobile, which really means we're going to design for mobile first. So you think about a paper map like USGS topo map, that's offline, doesn't need any battery, just needs some light. You can take your pencil, you could take your compass, you're good to go. But now that's designed for paper. Now what about searching for points of interest when you're offline out in the backcountry, say Joshua Tree? Maybe you want to find a campground, a trailhead, a water source, or some other sort of point of interest feature. So another thing about this talk, I said everything's online. And there's these chapters. So the chapters, we're going to hit our mobile, open data. There's the tools, I'll fly by those, but we won't go into depth. And then the pipeline. And the pipeline is where stuff really matters. So when we go out to the backcountry, what we want to do is think about the story you're going to tell when you get back. Or whenever you look at a map, like in the map gallery, those all tell stories. But there is some sort of navigation factor. I mentioned the paper and pencil and the topo map. Once you have a mobile map, you've got you can do a search for campgrounds like we're doing here, or you can get a rich set of information that's available offline natively. You can look for peaks or trailheads, as I mentioned before. Okay, so you want to be, when you make maps, you want to think about experience, okay? So you want to think about planning ahead and preparing. You want to think about your navigation. You want to be prepared in some sort of computing circles. It used to be called read the manual. And then you just want to be smart and use your brains. So we want to be prepared. This is why we have mobile maps, because the distribution of this geospatial data is there, and it helps with people to go enjoy the outdoors. What I want to get away is an app that just takes up your time and something to post to social media or is part of the tracking economy. We all have enough of those. We don't need more of those. Okay, so with mobile, you can have a distribution of spatial information, okay? This is the reason why you go out to Joshua Tree, to get this view of the solace that's out there. There's no service, and you can truly be offline. And when I talk about mobile first, I mentioned this earlier, it means natively offline. So another thing I call it is design for airplane mode, okay? So what that really means is that you have to build, I have to build my own raster and vector data sourced on authoritative data sources. And then I have full control. I have full control for mobile, for print, for web. I have full control. I have license-free public domain data sources. If you ever needed to get an update, you just use the app stores that exists. And when you have map data that you preload into an app, you have a serverless map. You have a truly serverless map. You can debate what serverless means, but you truly have a serverless map. Okay? So when you have a serverless map, we don't track your location. We don't get any pings on your IP address. There is no privacy leakage. We don't, and in fact, our other features, we don't track your location. We don't have analytics. We don't care where you go. We just want you to be safe. So on privacy should be a big deal to people. I mean, just a quick show of hands with your right hand, how many people used a map today to navigate? Okay, how many people used a map that they were confident on the privacy of that map? Doesn't matter if you use Apple Maps, Google Maps, any sort of other maps, Mapbox Maps, Cloak and Tech Maps. There's some sort of tracking involved somehow. Either you're serving up tiles of where you are, or they're tracking other meta information. So just by virtue of not tracking information, your security and your privacy increases immensely. Now, I wanted to talk a little bit about the data sources, and I'm going to have to fly through this. So a lot of the data sources we get are OpenStreetMap, openmaptiles.org, which is out of Switzerland. The USGS has beautiful sets of data and maps, and in the presentation you'll have to hit it yourself, but there's a bunch of stuff. Forest Service has an immense amount of great data out there on trails and roads. The National Park Service, of course, has 2 sets of data sources. The symbol library, so why go make your own tent icon when they've open sourced tons of icons? As well, they have trails, raw trail data. The NGA produces data for UTM grids, which are a big deal for backpackers. Wilderness.net produces data shapefiles of wilderness boundaries. And wilderness.net is a great resource out of the University of Montana. And then the tools. So I'm going to fly by the tools. I'll just mention it by name as we go. So GeoJSON's a big deal. The OSGeo suite of tools. Mapbox's tools. QGIS is a big deal. Cloak and Tech is a big deal. Docker is a big deal for all this stuff. And Google. Now I got to go into Google here to talk about 2 things that they're big on in terms of technologies. One is WebP for compression, and another compression, which is not imaging compression, but just compression or data minimization, is something called protobuf. So on the pipelines, I have 2 sections here about vector pipelines and raster pipelines. By the way, if you have a group that wants to hear this talk, I'd love to call in and give you an idea of what kind of stuff we're doing here. But I have to go through this one. We talk about raster data. Usually you think about PNG or JPEG as your unit of choice, your atomic unit of choice for raster. I've come up with something, not come up with something, but I've adopted something called WebP for raster compression. In Apple iOS 13 now, if you want to download an app that's over 200 megabytes, you can do it without being prompted. And on this little data set is one more. I have a set of apps, minor and bold, apps that are with this little logo or something that could have a map in it. And then it gives you the size of the app size. Just look at this column. Unfortunately, I don't have time to explain what's going on here, but I can offline. But basically, Apple has a cutoff of 200 megabytes of apps you can download without having to be on Wi-Fi. And I can't for the life of me understand why Bank of America is almost a half a gig, approaching half a gig. I think I'd rather just go out the browser or try a different bank. Facebook, you can't download it unless you're on Wi-Fi. But these kind of apps, these airplane apps, they're getting large also. And I would hope they would have pre-installed airplane maps, airport maps in there. Who knows if they do? That's just to be done, to be determined. But all the way up at the top is the smallest is Mapbox. You know you're going to go get maps, so it should be as small as possible. So if you're going to go out to Joshua Tree, it's only 100 megabytes, which is tiny. So that's that WebP compression. Apple is Apple. They use a different compression called HEIF, high efficiency image file format. And one of the cool things about that is it's natively supported in something called Apple Books, the Apple Books product. So I already had on my laptop, I had this stuff ready to go, but you can just hit some of these links and go check it out. I have a comparison of HEIF versus PNG for a topo map and a satellite map. And if you look at a topo map, this is what a HEIF file size is for an atlas of images, so a bunch of images piled around an area in Oregon. And this is what the size of PNG. Now, what we're doing is we're improving the experience by having a smaller app to download. And for orthographic rasters, the HEIF compression is much, much greater. So I'll just let these live demos run, but if you have any questions, I'd love to speak to you about offline maps for mobile. I've been researching this literally for 3 years, all self-funded. I'm a solo shop in San Diego, and I'm Rob Chohan, and I make offline maps for mobile. Thanks.